All right, let's look at chain rule when we have a composite of three functions. So instead of just a function in a function, like f of g of x, we might have like f of g of h of x, right? There's three things plugged into each other. The first thing is recognizing when you're in this scenario, there is one of these, not too complicated, but there is one of these on the derivative mastery test. All right, one way it might kind of hide a little bit is this, because think when we have a exponent on a trig function, we like to shorthand write it here so that we don't have to use so many parentheses. Remember when we have this on a trig function, so cosine to the fourth, what it really means is this whole thing times itself 4 times. And so if I write it in this other notation, then maybe it's a little bit more obvious that like cosine is plugged into the something to the fourth function. And then this 7x squared plus 1 is plugged into cosine, like a function in a function in a function. It reminds me of that movie Inception where they go like a dream and a dream and a dream. So we got functionception here. All right, so the biggest thing is going to be organization. And so we could use a lot of labeling maybe to try to keep straight our like inside outside type thing. So if we're trying to look at the whole equation at once, notice the something to the fourth is our main outside function, right? Because our goal is to eventually have the derivative of this whole thing. So the derivative of something to the fourth is 4 something to the third. So there's the derivative of our main outside function. Then we have to multiply by the derivative of the inside. The piece we'll have to be a little careful about here is that the inside itself uses chain rule. So sometimes it's not a bad idea to think, okay, we're trying to take, you can either write down and put a little dash, like we're going to finish it or do it later. Maybe we'll do that for right now. And then we'll kind of zoom in. Here we'll do it for real on the screen, but kind of mentally we'll zoom in. We can focus on. So we haven't taken this derivative yet. Two notations or ways to say, hey, I still have to finish this is I could write d dx out front, say still need to take the derivative of that. Or if we're just trying to shorthand, we can do this little dash, meaning we haven't finished this piece yet, right? We still need to take the derivative of the inside. The outside part we're done with though, because remember we don't touch anything inside, even if it's two functions when we do the derivative of the outside. So if this was something to the fourth, it's now 4 something to the third. And so derivative of the outside is done. All right, so now we just need to focus on this cosine piece. We'll get ourselves some space here and focus on, we're taking the derivative of cosine of 7x squared plus 1. We need to work on this derivative of the inside piece. All right, so notice this is just regular chain rule. Now we only have two pieces. So derivative of cosine is negative sine. And when we do the derivative of the outside, right, we don't touch the inside yet. And then times derivative of the inside is 14x. So we have 14x negative sine. So this whole derivative of the inside piece turned into this. And the reason I tried to hide the other stuff there for a second is so we just focus on one thing at a time, right? This is the organization. We'll put it back where it goes. Now we've taken the derivative of this, and we know that it's the same as this piece here. So we have 4 cosine to the third. This is the same thing. I'm just making it look a little nicer so the writing doesn't take up so much space. And then times negative 14 sine of 7x squared plus 1. And so we're essentially done, except since this is multiplied, we could maybe clean it up a little bit and say, okay, this is negative 56, right? 4 times negative 14. Oh, and I lost my X from down here. Here's a piece of the organization. The biggest mistakes, or the most common ones, are just forgetting to write stuff down. So I just copied that down wrong. So 14x went up here. So 56x. And then I have sine times cosine or cosine times sine. It doesn't matter at that point what order you put them in. So sine of 7x squared plus 1 times cosine to the third of 7x squared plus 1. So I'd say the hardest thing to do when you have a function in a function in a function is keep the pieces straight. But one thing that helps is kind of labeling. You could say, okay, here I'm focusing on the outside, here I'm focusing on the inside, and then go do your inside work off on the side of the page somewhere. Make yourself a little bit of space, and so that you get down to a nice final answer. All right, let's try one that looks more similar to the one on the derivative mastery test. So we'll go square root of 3x plus 5 to the fourth minus 2x plus 1. All right, so first, so they're asking us to take the derivative of this entire thing, recognizing that we have a function in a function in a function sort of thing going on here. Our outside function is actually the square root. And remember, if we want to, one good way to be able to see the power rule a little bit easier is to rewrite square roots as to the 1/2. So if I have square root of this entire thing, that's the same as saying I have this entire thing to the 1/2 power. Then maybe it makes it a little bit easier to see, like the something to the 1/2 is our outside function. And our inside for that one is this something to the fourth minus 2x, basically everything that's in the parentheses. But then this one has an inside of its own. So there's a function in a function in a function. All right, so if we focus on the very outside, the derivative of something to the 1/2 is 1/2 something to the negative 1/2. So notice when I do that outside step, if I want a little abbreviation, so I'll just write out. When I do that outside step, I don't touch anything inside. It doesn't matter how much stuff is in there. So this is still 3x plus 5 to the fourth minus 2x plus 1. Just leave that whole thing alone. All right, then I have to do derivative of the inside. So if I'm focusing on this piece, or derivative of the inside, maybe we could go, since these are separate terms, we'll do the easier parts first. So derivative of negative 2x is negative 2, and the derivative of plus 1, a constant, is 0. Then this is the part where I also need chain rule to be a little bit careful here. So I have something to the fourth. The derivative of that is 4 something to the third. And I leave the something alone, so 3x plus 5 isn't going anywhere. But then I have to multiply the derivative of the inside there, which is 3. So notice, like, we can ignore the 1/2 stuff and just kind of focus on this for 1 second. Did we correctly take the derivative of something? 3x plus 5 to the fourth would be 4, 3x plus 5 to the third times the inside, which is 3. And then we did our separate terms separately. So minus 2x is minus 2, and plus 1 was 0. So it looks like we're good. Now we can just clean it up a little bit. Anything to the negative 1/2 means it's in the denominator, and the 1/2 means it's the square root. And notice this is in the denominator, right? 1/2 is 1 in the numerator, 2 in the denominator. So I could put my whole square root back down here. And then all of this will be multiplied on the top. So I have 3 times 4 on this term, so 12, 3x plus 5 to the third minus 2. And then we could simplify a little bit further if we wanted to. I wouldn't probably take off points for this because it's so small, but everything, this term this term and this term, everything there is even. And so if we divide everything by 2, we get 6 and minus 1. So that is very similar to a function in a function in a function, or composition of 3 functions example that shows up on the derivative mastery test.